everyone, welcome back to our YouTube channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have one of our students, Anderson, who has completed the course ROS Basics in 5 days. This is in C++, and at the end of this course, you can take a project implemented on a real robot. So that's what we're going to be seeing here today. So hello, Anderson, how are you?
Hello, Rodrigo. I'm fine. Good to see you again.
Good to see you again as well. I'm excited to see your presentation. So whenever you want, you can start sharing your screen and show us what you've accomplished here.
Okay, so first I will share this entire screen here. Let me know if you can see.
Yes, we can see it.
Okay, so here I have the robot, here the shell. Um, I will put here in one of these. I will put the just to see the results. So I am echoing this topic just because I want to see the result at the end. Uh, I want to see the feedback, continuous feedback here. I will put it there.
Oh, that's great.
And on this third one, I will launch my launch file. So
Okay.
let's see. Okay. Okay. It started first searching the wall and then until it finds it, and then it tries um, to adjust the orientation, the attitude
Uh-huh.
regarding the wall. So you start following the wall and keeping the distance, the safe distance from the wall, but to the best that you can, it tries to go closer to the wall. Okay, so first corner, second corner is fine. Actually, Rodrigo, this is my second live exam. So basically here is the same implementation. Later I can give more details when I show the code.
Okay.
And basically what is the general algorithm, let's say, for performing this movement is exactly the same. I didn't change variables or the limits is the same thing.
The
But
same thing.
when I show the code, I would like to mention something that I learned. So it started more or less there, close to the
Right.
arrow, and here for this I defined a big square that once it goes out and then it goes inside of the square again, it understand that it uh, finished one of this cycle. Okay, so this is the demonstration.
Awesome. Great.
It,
That was perfect.
okay. Okay. So I'm sorry, I forgot to show. So while it was working, maybe it's even better if I run it again. So while it was running, but it was providing
The
the
feedback.
the distance. So it was echoing the distance that it had followed up to the moment. And what we see in the end, so here's the distance 0.5, 0.6, how it was
Mm-hmm.
how it was moving, and what we see in the end is like the collection of all those points, X, Y, and Z is a kind of trajectory followed by the robot.
Great. So that second
Okay,
terminal, 729, that's the feedback, right?
yeah, exactly. So here you see the feedback.
Okay. Great.
So see here, I'll stop, record on feedback.
Oh, okay. You can leave it running, by the way.
Okay, okay. So let's go to the code editor.
Awesome.
So
Yeah, I'm interested to see how you did it.
okay, so basically, uh, I would say that especially because this is the second time that I'm doing something that is so close or so similar to the last time,
Mm-hmm.
to the last task, uh, I would say that the things, the knowledge, I would say, was more solidified. So I knew better how I could proceed in achieving the same result. And it was
Mm-hmm.
not the case that I simply took the code written in Python and I translated. No, I pushed myself to try to do the same thing from scratch.
Mm.
But even though I made it from this scratch, I didn't take the same time. I mean, it was like half of the time that I took when because when you try to do something for the first time, it requires some tests but these worked in the very first attempt.
Absolutely.
What I- so the case here, so what I have in general sense, so is a main C++ file where first of all, I call the service. So here I have the call of the service. I, so I have the request. So, and then in the service is where I adjust the orientation of the robot. So here I follow something that is similar to, um, I think I described this to you last time. I don't know if you remember that
I do
I
not.
developed I developed a kind of um, uh, how can I say, some robust algorithm to identify when it is a wall, when it is a pole, differentiated then this kind of
Awesome.
stuff in a very very simple way. So it evolves in this until it find the position, the correct orientation, then informs the main program that since that moment it start the action. The action is where effectively we calculate the distance followed by the robot, and in the end it detects. By the way, let's see if it stopped. Yeah, it stopped there. So and then in the end it detects the robot finally achieved the point where it started, or close to that at least, depending on the size or how close I want to be on the starting point.
Uh-huh.
And here, just to not take too much of your time, I can mention for example some things that I saw that it was different when compared, especially to the Python implementation. For
Yeah.
example, when we define a type that is kind of 0.32, this is something that I really don't have to take care about this in Python. But here, because it's C++, in order to deal properly with this kind of structure, I had to separate them. The same thing happened here, for example, when I have to post the odometry.
Mm.
It was simple in Python. It was simply moving because I use the kind of ROS info. But
The logger.
here
Yeah.
it was necessary this separation that made him understand the kind of data it was dealing with.
I see. I see.
Uh, and that's it. I mean, the general structure is that. So it's a main program that calls the service, and then possibly something that I could improve here would be this thing of the size of the square that I told you. Let me show. At some point, I defined the here. If it is out of the square, then it calls some. So actually, I defined the square that is like 20 centimeters because I really wanted to make it stop. Sometimes because this trajectory is not a strictly perfect, maybe it will not pass, it will not go back exactly to the point where it started, and then it will stay like running and running.
Yeah.
So
Yeah. Yeah. Making it bigger. It's. I keep getting this comment, and I'm just gonna end up increasing that to, like, let's say 25 centimeters, so people don't worry about that too much.
And yeah, and that's it. I think that with these here is more like just following and calculating the distance, just this, and
Uh
here
huh.
the part of finding the orientation, and here what is the main task? Actually, something pretty simple. And it's
Yeah.
just a
Yeah. I
matter
love
of
that. Super
comparing.
simple. Great.
That's it.
Is that it? Awesome, awesome, Anderson. So let me congratulations. Very, very nice,
Oh,
nice project. Very straightforward, and you know, um, very,
thank
very
you.
smooth movement. And I like how simple it is. I got a couple of questions, if you don't mind.
Please, please.
Uh, so the first one would be, You mentioned that you implemented and you talked about this in your last presentation. You did ROS Basics, but in Python last time. And
Exactly.
I'm sorry, I don't quite remember because there's so many students that present. But I guess my question is, could you just talk about this simple detector? Because that's very interesting, and the simplest. I like simple solutions like the ones
Uh,
you're showing here. So I'm kind of
yeah,
interested in how you solved that, and
yeah.
remind me,
Actually, this
please.
this was something, especially after talking to you. I I kind of could see how elegant the because it's just these two lines, you know.
Uh huh.
And fortunately for this kind of robot and for this kind of poles and whole environment that we have, they work pretty fine.
Yeah.
The general idea is basically this: I compare two two beams of the sensor. So if the distance, the value that I collect from them, so I have one that is just in front of me, in front of the robot, sorry,
Mm-hmm.
and the one that is a bit aside, one that is like 60 beams away from the frontal one. So if you compare them and the reading of these, the measurement of these is something like is something discrepant, something that is pretty distant. What you have is something like possibly you have something that is narrow in front of you. These I characterize as a pole. Instead, if you have some similar, so here I define what is considered similar, what is considered completely different. If you see something similar, possibly you have something broad, something large in front of you, and then you will have a huge difference. When I mentioned this idea to you last time, you also mentioned that depending on the angle that if you have like the orientation of the robot and the position of the wall when compared to the orientation of the robot. Possibly you will see a big difference between the two beams. But for all the tests,
Mm-hmm.
100%, all the tests that I did, it worked fine. I mean, because of these values that I managed to find here, so it could detect. And another curiosity is that it became even easier when you guys you changed the kind of poll because in the past, in the recent
Ah,
past, it was
it was
it was
wider.
yes,
Uh huh.
and now it's more like it's even narrower.
It's an
So
abrupt interruption in that scan, so your filter works better, huh?
exactly, the filter
Ah,
works better.
interesting,
Exactly,
interesting,
exactly.
interesting. Awesome. And um,
I mean I know that is something pretty simple, especially to you. I mean you were an expert to that, but
no,
it's
but
something that
I rather have those things. And like you said, if it's two lines of code and it works 100% of the times, why the need to complicate it? Of course, you can do it to, maybe get some learnings, more learning out of it. For example, we had a great presentation before you. Um, and I hope if he's watching, it's not a critique, it's just a comment. His name was Adrian, and
uh,
he developed a proportional controller, three proportional controllers,
okay,
in
okay.
order to achieve the movement, which is great. It shows initiative. It shows that there's it's a step further for what we explicitly say in the
Mm-hmm.
in the project, uh, but it introduced some new potential sources of error. And a lot of
Definitely,
the times,
definitely.
especially in robotics, when things grow out of control very quickly, if you don't manage it closely, uh, you have to, in my opinion, it's a better option to go for the simple. So as simple that accomplishes the task 100% of the times. 100% of the times in simulation is not the same as 100% of the times in the real robot. So
Yeah.
also you have to keep that in mind, but keeping it as simple as possible reduces the amount of errors you can have. And
Yeah.
I mean, for example, I saw your movement and it almost looked like it wasn't three if else statements, right? And it
Mhm.
accomplished the task perfectly. So
Exactly.
in all of my projects, I always try to stay with that philosophy, to build that something that works instead of building a race car right out of at the first time. You start with a little scooter, right? Two wheels,
Yeah.
and then all right, that gets me there. All right, if I need to, I'll bring it to a tricycle or whatever, and then I'll end up with that race car. But if you can finish the task with a normal little scooter, you don't need the race car. So that's sort of the analogy I take with it, and I think it's very important, especially in
I,
robotics, because this simple behavior can just explode into so many different things, and to keep things short, like your filter, is the way to go, in my opinion. So
I really, yeah. So thank you very much for your words. And in fact, this describes very well my philosophy. I think that at some point, because you express yourself in your code, so it's almost
exactly.
artistic that the way that
Oh
you
yeah.
solve the problems. As you said, there are infinite ways of solving the same problem, and some of them are pretty sophisticated and includes a lot of knowledge. But one thing that I try to do is like I don't add more complexity than it's necessary. So
Yeah.
for these, I mean, I found this solution and I thought it was pretty elegant. Something, and remember, there was not even a feature, characteristic that was requested by the
Absolutely.
challenge. It
Yeah.
was something additional. So I was already doing something. I said, no, it doesn't need to be too complex.
Right, and
But
maybe you did it because you kept running it, and it kept seeing the obstacle, and maybe it was going towards there.
yeah, yeah. In fact, when I was trying for the first time for the first
Uh-huh.
live exam, in fact, it happened. Many times it was like I had like the posing random position. So
Yeah, people move
I
it all the
wanted
time.
something smart enough to say
Don't go towards
to
there.
solve the problems. Yeah,
Yeah,
exactly.
yeah, yeah, yeah. I was gonna say yes. The obstacles are move around. Some people reserve the robot. I joke around. Sometimes people reserve the robot just to move the obstacles around and to put them in in the most awkward positions. But yeah, that's an extra thing. The environment changes in the simulations the same all the time. You know, maybe in the real
Yes.
robot it's a little curved, things like that. So it will affect your code. So yes, great. I agree with everything you say, and I love the fact that you even say that's sort of an artistry, and I agree. And I don't know if you use code in your work. It looks like you do. And
Yes.
if
I
that's
do.
the case and you follow that philosophy, I try to. I'm not very successful at it. But if that's the case, that means a lot of people appreciate looking at your code because, when you sit down and look at a written code and it's like, you even feel like a little better that you don't have to decipher it because a lot of people are, super smart. But then you take a look at their code and it's like, oh my God, this is going to take me like a
That's
week
it.
to figure out. So I agree 100% with you, Anderson.
And I would say more. I mean, I would say that for good readers, good code readers, as an specialist in art that can identify, oh, this is Picasso, this is, I mean, whatever.
Oh, yeah.
Some you can identify a good writer if you see code well organized in a simple way, elegant. That is, I mean, you can identify. So this was probably written by Rodrigo because I mean,
Well,
so
I'll send you
so
some
yeah.
of my code to see if you can decipher it. But yeah,
Okay.
awesome, awesome, Anderson. I mean, those are some great points. I just want to say congratulations again. I hope you take the step further and maybe do some things like autonomous navigation and things like that. Then we can take a look at what you come up with those projects, Anderson.
Sure. Actually, I'm already attending other courses, so I expect that in the near future I will implement more sophisticated, you will see great stuff
Awesome.
coming.
And just out of curiosity, is there a
Yeah.
specific reason why you're taking the ROS as opposed to ROS 2 courses?
Yeah, so I work in academics, and I would say that at this point, maybe ROS one is still more widespread,
Way
more
more
popular
resources. Yeah.
than ROS two. I see that is a movement that is changing this, but I wanted to start from the beginning,
Okay.
basically.
Yeah.
So I did ROS one, and I will naturally move into ROS two. That's it.
Interesting. Yeah. Yeah. There's still a lot more resources, open source packages, things that you can reuse in ROS than ROS 2, but it is getting there. And there's going to be disadvantages, especially, well, now, if you use Linux, for example, um, the ROS stops getting maintained and it's going to be only available in Ubuntu 20 and before. You won't be
Uh,
able to, you'll have to install it by source. It's just going to be a little more difficult. So I recommend take a look at the ROS 2 because it's the same thing, basically. Once you get into the structure and architecture of it, there's a big difference. But let's say you won't run into problems until you try and have a network of multi-robot systems
okay.
without a ROS core. So, but we'll leave it at that. And thank you,
Okay.
Anderson, again for showing us your project.
No, it's my pleasure.
All
My
right.
pleasure.
All right, everyone. So this is your opportunity to do what Anderson did here, to show what you've done in our course and show that you've actually taken something of value out of it and show in a presentation. And that way we can be confident to give a certificate of learning from the construct because they mean something to us. So I invite everyone to do what Anderson did here. And Anderson, thank you one more time, and I hope to see you around very soon.
Thank you. Thank you for
All
having
right,
me,
guys.
and
Okay.
see you.
Bye bye, everyone. We'll see you next
Bye.
time. Bye.
Bye.
All right, Anderson. Cool. We're done.